You are welcome to GMAETS41 Basic Class channel. So, to our dear basic scholars, friends in basic 4, 5, 6, 7, 8, and 9, I'm using this opportunity to warmly welcome you to this class. So, we are going to look at reduction of fractions today, part 3 of fraction. But this class is actually a continuation of our last class. Okay, because in our last class I introduced reduction of fraction. Okay, I introduced reduction of fraction, but we could not complete it. Now, as we're about to kick off this class, please, I want to appeal as usual. If network interferes, if network interrupts, stay tuned. Don't log out. Are you getting me right? Just stay tuned. I will boost the network in my own way, and you will be automatically logged in again, okay? You know, you want to be tough as GMAETS41 is. Quickly, let me share what happened this evening. I had just had a 1-hour class on this reduction of fraction, this particular class. Sadly, I don't know what happened to the volume. You can see, huh? And there was no voice effect. I don't know how come. But then, even in the process of the class, our power holding company struck as usual. And then I was resilient, made a way out so that I provided a little lighting system, but never knowing that the voice effect of the live class was not active. Okay, but now I had to come on once again to hold this class. So be as tough as GMAETS41. In our last class, I introduced this topic. All right, so without wasting time, we are going to continue. Just as a quick, we have the continuous division method, and of course, we have the prime factorization method. Network disturbed us in that previous class towards the end that the prime factorization method did not show up very well. So in this class, we're going to see that, though I'm still going to be teaching you the 3 methods. And I remember telling you that on GMAETS41, we will be using the HCF method, and alternatively, the continuous division method. But let us see this first question, okay? Our first example today, but I'm going to write it as example 2, because example 1 had already been treated from that previous class. So in this example 2, we have this question. Let's go straight. Example 2. Okay, and let's see the question we have here. Reduce 75 over 125 to its lowest term, Solution. So I want to find out how we can reduce 75 over 125 to its lowest term. We are going to use the 3 methods, and I'll be fast in doing this. But remember the secret of this topic. First of all, an excellent knowledge of multiplication. At least you want to know your multiplication table at heart so that you can say it offhand, at least from 2 times to 9 times table. at least from 2 times to 9 times table. Very important. Very important. Because the knowledge of multiplication is going to guide you through to be able to solve questions faster, applying any of these methods. Then, after this knowledge of multiplication, it is advised that a student, a pupil, should also have good knowledge, very good knowledge at that, to excellent knowledge of rules of divisibility. Rules of divisibility. Time and again, I'm going to go behind to check the camera and check the network situation rather through the camera, so that we don't have the same problem we had last time. So we are solving 75 over 125. Let me check the network situation before I solve this question. All right. So I'm going to boost the network a bit. I'm going to boost the network a bit. All right. So there is a question here we have on the board. We are going to use the 3 methods. Let's start first with the first and most important method. Yes, the HCF method. HCF method. HCF method. All you have to do is to find the HCF of the numerator and denominator. We have 75 over 125. So what is the HCF of these two numbers? The HCF is 25. And how can one quickly know the HCF? The fastest way is, of course, knowing your multiplication very well. Now, look at this number. From the knowledge of multiplication, I know that 5 can divide this. Using rules of divisibility also, you agree with me that 5 can divide this 75. Any number that ends with 5 or 0, 5 can divide it. Any number that ends with 5 or 0, 5 can divide it. So look at this 75, 5 can divide it. And if 5 divides 75, you are going to get 25. That 25, 5 can still divide it again. If 5 divides 25, it will give you 5. So how many 5 have you used to divide 25? To bring it, if 5 divides 25, right? If 5 divides 75, rather, you are going to get 15. Yes, you're going to get 15, please. Not 25. If 5 divides 75, you are going to get 15. Then 5 can still divide that 15 to give you 3. So how many 5s have you used to divide 75 so as to get 3, which is the smallest term? You use 2 5. That 2 5, now if you multiply them, 5 times 5, you get 25. That is how I got to know that 25 can divide this. And 25 is the highest number that can divide 75. Therefore, I am saying that 25 is the highest common factor of these two numbers, because 25 can also divide 125. So here I am going to write HCF of 75 and 125 is 25. This symbol in mathematics means it implies. Okay, it means that. It implies. So the implication of this is we are going to use 25 to divide this number. So we have 75 all over 125. You are dividing this by 25. You are also dividing the denominator by 25. So let's go. If 25 divides 75, you are going to get 3. If 25 divides 125, you are going to get 5. And look at this 3 in the numerator and 5 in the denominator. No common number can reduce both of them. You can't have any single number that can divide 3 and divide 5. Therefore, you have gotten your answer. Remember, I told you from that last class that the HCF method gives you your final answer directly. Once you divide, you get your answer. So 75 over 125, the answer is 3 over 5. 3 over 5. That is the answer. Very simple. Very simple. Now, I would like to say something. The knowledge I use to actually get the HCF here is the idea of rules of divisibility and or continuous division. Okay, like I said, I found out that 5 can divide 75 to give you 15, and 5 can still divide 15 to give you 3. So I found out that 2 5s can divide 75 to reduce it to 3, and 3 is the smallest term that 75 can reduce to, whereby no other number can reduce 3 apart from 3 itself. Okay, since I used 2 5 to reduce 75 to 3, that 2 5, I'm going to multiply both of them. 5 times 5 will give you 25. So from there, I get the highest common factor, which of course applies to 125 also, because 5 can divide 125 to give you 25, and 5 can still divide 25 to give you 5. So 2 5s again reduce 125 to 5. In fact, we'll see it in method 2. Method 2, continuous division. Continuous division method. Good. The continuous division method requires that you have good knowledge, excellent knowledge of rules of divisibility. I have 75 over 125. So we want to continuously divide. Please, in case power holding company strikes, as usual, they celebrate that. It's their normal thing. Just be patient. I am going to put on a manageable lighting system that would use to complete the class. So from here, find the smallest number that can divide 75 and 125. Just like using LCM to divide. Just like using LCM, that you're solving the LCM of 75 and solving the LCM of 125. What is the smallest number that can divide? Okay, so let us look at 75. Now, 75, 3 can divide it. 3 can divide 75. If 3 divides 75, you are going to get 25. How did I know that 3 can divide 75? If you do 7 plus 5, there are 2 digits in 75, 7 and 5. If you add both of them, you will get 12. You will get what? 12. Now, 3 can divide this 12. The sum you obtain, the addition, the result you obtain when you added these 2 digits, 3 can divide it. Therefore, 3 can divide 75 also. That is the rule of divisibility by 3. I talked about that in the previous class. So let's move on. Now, I know that the smallest number that can divide 75 is 3. But can that smallest number 3 also divide 125? Let's find out. In 125, you have 1, 2, 5. If you add the digits 1 plus 2 plus 5, you are going to get 8. Can 3 divide 8? No. Since 3 cannot divide 8, it means that 3 cannot divide 125. 3 cannot divide it. Are you following, right? Remember, in this case, you are looking for a number that can divide both of them at the same time. Okay? But if I decide to say, okay, let me use 3 to divide this and then another number to divide this, it's still okay. But I want us to find that common number that can divide the numerator and denominator. 3 cannot do that. 4 cannot do that. In fact, the first smallest number that can divide both of them is 5. So I'm going to use 5. If 5 divides 75, I am going to get 15. I'm going to get what? 15. Then if 5 divides 125, I am going to get 25. I'm going to get 25. So do you see, I've used 5 to reduce as the smallest common number that can divide 75 and 25 and 125. Are you following, right? So the next thing is to think, is there any other number that can divide 15 and 25? Yes. At this point, 5 can still divide. If 5 divides 15, you are going to get 3. If 5 divides 25, you are going to get 5. Rules of divisibility by 5. Any number that ends with 0 or 5, 5 can divide that number. That is how I got to know that 75 and 125, 5 can divide both of them. And look at this, 15 and 25, both of them end with 5. So 5 can divide both of them. Now, 3 and 5, there is no common number that can divide both of them again. Therefore, you have gotten your answer. We can now conclude. 75 over 125, the answer is 3 over 5 as before, the same as we obtained in method 1. Answer. Now we are going to look at the third method, method 3, the prime factorization method. Let me check that the network is intact. Okay. So I think we are there. Let me adjust the camera a bit. Let me adjust the camera a bit to the left. Good. All right. So we look at method 3. Method 3. Method 3 is prime factorization method. Prime factorization method. I am teaching you this prime factorization method so you could just know it in case your teacher asks you to use this method. Okay, because the teacher can ask you, use the prime factorization method to reduce a fraction. But for me, I don't see it necessary anyway. Okay, so just learn it in case you're asked to use the method. But if you find yourself in exam hall, please use either the HCF method or the continuous division method. It is better and faster. Now, in the prime factorization method, you have 75 to be divided by 125. So what you have to do is to think of the prime factors of 75, prime factorization of 75. And how do you get it? Always activate the network of your brain. And like I said, the knowledge of multiplication is what you need. Once you have good knowledge of multiplication, you have conquered division. I'm going to tell you this quickly before we handle this. If these two markers are being multiplied, let's assume they are numbers. You multiply this black marker by this blue marker, and it gives you this red marker as your answer. Black marker times blue marker equal to red pen as answer, for example. Therefore, this answer, red pen, if you divide it by this blue marker, it's going to be equal to this black marker. Again, if you divide this red pen by this black marker, the answer is going to be this blue marker. The whole idea is that if two numbers are being multiplied to get a particular number, that answer, that particular number answer you got, if you divide that answer by any one of the two numbers you multiplied to get that answer, if you divide that answer by any one of the two numbers, you will get the other number. So if this black marker and blue marker multiplies to give you this red pen as answer, this red pen as the answer divided by this blue marker will give you black marker. This red pen divided by this black marker will give you the blue marker. So that is just a trick. An application of multiplication to solve division. So division depends on multiplication. That is why I always advise you pupil, you student, you basic scholars, take your multiplication seriously. And one thing is that some people will think multiplication is simple, it's for children. Yeah, we know, because you keep practicing, but the application goes wide. It goes to all levels of education. At least, if not for anything, humbly appreciating my 18 to 19 years teaching experience, having taught at primary school level, that is basic level, at secondary school level, both junior and senior, and then at the university level. I am telling you that once you understand, you know your multiplication at heart, at least from 2 to 9 times table, you have conquered calculation. You have conquered calculation at all levels. Any subject about calculation will become easy for you. So whatever anyone is telling you, the tricks in multiplication and all that, fine. See, the first and most important thing is memorize it. Know this table from 2 to 9 times table. Practice them, have them at heart, so you can be able to say them offhand as fast as possible. Like I said, it will help you to conquer anything calculation subject. Now let us apply this knowledge and see what we are going to do, what we're going to get. So this 75 divided by 125, we have to reduce it using prime factorization. So I'll ask myself, just the same way as you solve LCM, if I give you 75, find the LCM. You start from the smallest number. So what is the smallest number that can divide 75? If 2 can divide it, then you start with 2, but 2 cannot. The first smallest number that can divide 75 is 3. So I'll come here and then I'll write 3. If 3 divides 75, you are going to get 25. So I'm going to write 3 times 25. But I'm not going to show the 25 here. I'm not going to write that 25 for you. Why? You should know why. Why is it that I'm not going to write the 25 here? Because look at the 3 I used in dividing 75. If 3 divides 75, which is 75 divided by 3, you should get 25. So I'm meant to write 3 times 25 here. But why am I not writing the 25? Because 25 is not a prime number. So here somebody can now ask, okay, what are prime numbers? Prime numbers are numbers that have only 2 factors. Numbers that can be divided only by 1 and itself. A prime number does not have 1 factor. A prime number does not have 3 factors, 4 factors, 5 and above. No, it has only 2 and 2 factors. Like I said, 1 and itself. For example, this 3 is a prime number because only 1 and 3 can divide 3, which are the 2 factors. 5 is a prime number because only 1 and 5 can divide 5, which are 2 factors. 7 is a prime number because only 1 and 7 can divide 7, which are the 2 factors. 11 is a prime number because only 1 and 11 can divide 11. 13 is a prime number. Only 1 and 13 can divide 13. So a prime number cannot have more than 2 factors. It's only 2 factors, 2 and only 2 factors. It can't have 1 factor and it cannot have more than 2 factors, like having 3, 4, 5 and 6 factors above. No. Now, if 3 times 25 will give you 75, yes, if this 3 divides 25, divide 75, you get 25. I am supposed to write the 25 here, but why I won't write it is because 25 is not a prime number. And I'm going to tell you why. 25, 1 can divide it, which is 1 factor. 5 can divide 25. They have gotten 2 factors. 25 can divide 25 itself, making it how many factors? 3. So you see that 25 has 3 factors. Therefore, 25 is not a prime number. And that is why you are not allowed to write it here. So this is what we are going to do. Here, the network of our brain will be active. 3 times 25. Have the 25 in your brain now. Will give you 75. Now, that 25 can be broken down again to prime numbers. How? You ask yourself, which number can divide 25? Which number is the smallest number that can divide 25? And the smallest number that can divide 25 is 5. Which means this 3 times 25, that 5 will be broken down by, that 25 will be broken down by 5. So instead of writing 25 here, I am going to write 5, which will divide 25. If 5 divides that 25, you are going to get 5 as the answer. That is why 5 times 5 will give you 25. So you see, in place of that 25, we have written it or replaced it with 5 times 5. 5 is a prime number. So you have gotten all the prime factors of 75. Divide this by the prime factors of 125. Do the same thing. What is the smallest number that can divide 125? 2 cannot divide it. 2 cannot. How did I know? From the rules of divisibility. The last digit is an odd number. 2 can only divide a number whose last digit is even number or whose last digit is 0. On this channel, you have video lessons that cover all these concepts: HCF, LCM, multiplication, division, basic arithmetics. Mention them. Are you following right? LCM. So take them. I have taught you all of these. They are here on this channel. If you are following us, you will enjoy your learning. So 2 cannot divide. 3 cannot divide 125. I've already proved it here for you. If you add 1 plus 2 plus 5, you get 8. Since 3 cannot divide 8, it means that 3 cannot divide 125. 4 cannot divide it. 4 cannot. Okay? Once 2 cannot divide a number, 4 does not even have any place. The first smallest number that can divide 125 is 5. So I am going to write 5. If 5 divides 125, the result is going to be 25. Because 5 times 25 is 125. So if you have 125 divided by 5, you should get 25. Now, I am supposed to write the 25 here. If the 25 were to be a prime number, but 25 is not a prime number. So in this method, you're only recording prime numbers. Are you following, right? So this 5 times 25, that 25 will be broken down again. And what is the smallest number that can divide 25? It is 5. It is 5. So 5 will divide that 25, and you are going to get 5 as a result. If this 5, what you're using to divide, if it divides that 25, you get 5. These are the prime numbers or prime factors of 125. Now I have gotten prime factors of 75. I have gotten prime factors of 125. I can now start reducing the term. I can now start reducing. Look at the numerator, look at the denominator. What can divide? Now this 5 in the numerator can divide this 5 in the numerator. You will get 1 and 1. So we say just cancel the 5, cancel the 5. But please remember, whenever you are doing this issue of this number in the numerator cancels this number in the denominator because they are the same, remember, when the number divides itself, you get 1. Let me check the network situation. Let me check the network situation, please. Permit me to boost. Let me boost it, so stay on. The network went almost temporarily down. So I've just been struggling with it, trying to boost and boost and boost. Like I said, whenever we have this difficulty, please be patient, okay? I'm trying to boost it, let it come up so that we can continue the class. It doesn't seem to have come up yet. It doesn't seem to have come up yet. Please, could this network permit us to be done with this class? Please, if the network is okay at your end, could you type a message? Please type and indicate yes that the network is okay at your end so that I can continue the class. Is the network okay at your end so that I can continue the class? The network was temporarily down a moment ago. All right. Let me see if I can continue. It seems like the network is a bit okay through the camera, but it's not showing up here. So I don't know, I'm worried. I'm worried. All right, let's proceed. So these terms can reduce. If the 5 reduce this 5, you get 1, 1. The same thing, this 5 and this 5 will reduce. And you still get 1, 1, okay? Still get 1, 1. So at the end of this, what we now have is that 75 over 125 is equal to 3 times 1 times 1. That's what you have in the numerator. 3 times 1 times 1, which will give you 3 all over. The denominator is 1 times 1 times 5, which will give you 5. So that is 3 over 5. And that's the answer. The same as what we obtained in method 2 and method 3. Let me check the network situation. Check the network situation. Seems like the network is really quite down, but through the camera is still on. I don't know why it is not showing up on this device. All right. So this is how you apply the prime factorization method. Okay. So you apply the prime factorization method. And of course, you see that any of these 3 methods you want to apply requires excellent knowledge of multiplication and perhaps the rules of divisibility. Once you have excellent knowledge of your multiplication and the knowledge of rules of divisibility, these things are 1 plus 1. And remember what I said, we shall be making use of method 1, HCF method, and method 2, continuous division method on this channel. And that is what I advise you to adopt. That is what I advise you to be using. Learn them very well because they will help you to be fast in your calculations at school, in your examination. This prime factorization method, well, learn it for what it is. But personally, when it comes to solving problems, exam questions, please use either method 1 or method 2, the HCF method or the continuous division method. Except your teacher tells you to use prime factorization to solve, to reduce a fraction, then you can now use this method 3. Otherwise, just learn it and let it just be there. We are going to pick example 3. But let us check what the network situation is like. Example 3. Going to check what the network situation is like. Please copy what's on the board so we can go to example 3. All right, so let us move on to example number 3. I believe you have copied this, so I'll wipe it. And then we'll look at example 3. Example number 3. Let us see what we have got here. It is not funny struggling with network always. Example 3. So we are asked to reduce 16 over 20 to its lowest term. Solution. Let me abbreviate solution like this, SOLN. Are you getting solution? All right, so how do we solve this problem? It's pretty simple. Okay, it's a very simple problem. We have 16 over 20. I'll be using method 1 and method 2, the HCF method, and then the continuous division method. Okay, so I'll write the HCF of 16 and 20 is 4, which means we are going to use 4 to divide the numerator and the denominator. Therefore, it means that 16 over 20 will now be equal to, let's find out. Using 4, the HCF to divide. If 4 divides 16, 16 divided by 4 is going to give us 4. And then 20 divided by 4 is going to give us 5. You are using 4 to divide. In 4, it means you are working with 4 times table. In 4 times table, 4 times 5 will give you 20. So 20 divided by 4 is equal to 5. So if you divide 20 by 4, you are going to get 5. See, the HCF method is very interesting. The HCF method is very what? Interesting. Because once you divide, the network seems to be hanging and hanging again. The network seems to be hanging. All right. Let's see. It's working now. All right. It's working now. Let me see if I can boost the network once again, but I think it's just hanging and hanging somehow. All right, let's move on. Once you divide using HCF, the result you obtain directly is your final answer. Are you getting me right? Therefore, we conclude that 16 over 20 is equal to 4 over 5. If you use HCF to divide, what you obtain is your answer directly. Nothing can divide them again. Let us use the alternative method, method 2, the continuous division method, to obtain the same results. You will never see me use prime factorization method to solve fraction reduction generally, and I won't do that again. Except maybe ordinarily if I just want to teach you prime factorization or method, or just if I want to teach you prime factorization way of reduction of fraction, then I might just focus on that. Okay, let's do that, let's play. Apart from that, we are solving normal questions that we need to reduce fraction. You won't see anything like prime factorization there. That is why I told you, don't bother yourself too much about that method. Focus on method 1, HCF method, and method 2, continuous division method. So we have alternatively, that is the other way around. The other way around, if I don't want to use this method, I want to do continuous division. I will have 16 over 20. Through the continuous division, let me assume that I don't know the highest common factor of 16 and 20, that I don't know that it is 4. Assuming I don't know, I can start thinking, okay, what is the smallest number that I can use to reduce 16 and 20? And this is where the excellent knowledge of rules of divisibility comes in. Okay? The excellent knowledge of rules of divisibility comes in here. Now, this number ends with the digit 6. 6 is an even number. Any number that ends with an even digit can be divided by 2. That is the rule of divisibility by 2. 2 can divide any number whose last digit is an even number or 0. So if I give you any number now and it ends with 0 or it ends with an even number, 2 can divide it. So you can just think, imagine I give you 1,780, 80 what? Okay, let's say 84. 1,784. The number might be big for some of you, for the class you are, let's say basic 4 or basic 5, but you can answer it. If I ask you, can 2 divide it? Yes. Your interest would be the last digit. The last digit there is 4, so 2 can divide it. So that is how I got to know that 2 can divide 16. If 2 divides 16, you are going to get 8. And 2 can divide 20, you get 10. Remember, 20 ends with the digit 0, so 2 can divide it. So you see, how did I know that the answer is 8 and 10? This network, please calm down. How did I know that the answer is going to be 8 and 10? I used 2 to reduce. So you'll be dealing with 2 times table. 2 times 8 will give you 16. So 16 divided by 2 is equal to 8. 2 times 10 will give you 20. So 20 divided by 2 will give you 10. So I'm trying to track what is happening, via this device to know what the network situation is, but it seems the network is just hanging. Be patient. Let me see. I hope you are still there. The network is hanging, so it's not funny. It's moving now, still trying to hang and other things like that. This is not funny. All right, let's continue. This 8 and 10 can still be reduced. 2 can still reduce 8 and 10. So I'll use 2 to reduce. This network, please, could you pity someone? Be kind. It's just hanging. All right. 2 can divide 8. If 2 divides 8, you're going to get 4. 2 can divide 10, you get 5. Please let me boost the network. Patience, please. It seems to be hanging. I just tried boosting the network. Once again, let's see. So I think it has come up a bit. All right. So let us move on. Like I said, 2 can still reduce 8 and 10 to give you 4 and 5. We can now conclude. Therefore, 16 over 20 is equal to, the numerator you have 4, the denominator you have 5. So you have 4 over 5, which is still the original result you obtained, telling you that you are correct. Answer. So we are done with this second question. We'll be moving on to example 3. We have 5 questions we are going to solve. And I'll continue to struggle with this network until we are done with this class. Yes, I will fight and fight hard. No giving up. This is GMAETS41, right? So you want to be tough. Like GMAT is tough. Remember, this is basic level of learning. And you are being trained to be tough whenever you face tough situation. Don't just give up. Don't allow anything to frustrate you, even in your studies. When you see things that are making the whole thing challenging, when you see difficult work, you should get even much more difficult with the work. Be tough. That is the spirit. And you friends, you can do it, even if you're in basic class. Remember, this is the foundation of your learning. You build a tough foundation so that when you move higher, you won't have any challenge. Example 3. Example 3, let's see the question. Example 3. This third question is an interesting question. Evaluate 20 times 5 over 2 times 50. 20 times 5 over 2 times 50. You are asked to evaluate it. So how do we solve this problem? You see, although I have introduced division, I've introduced multiplication rather, but it does not matter. It does not matter. You are expected to divide before you multiply. That is what the rule of BODMAS explains. And I've taught you BODMAS on this channel before. You can check this channel through our live classes. You will see BODMAS class. I've taught you BODMAS. So you have to divide before you multiply. Okay? So this question is simple. Nothing is there. Let us look at it. God, the board is blurred somehow, right? Is it okay from your end? Is it okay? All right, type network is okay. If it is okay at your end, the board is a bit blurred. The board is a bit blurred from here. All right, let us move on. So here we have 20 times 5 over 2 times 50. Now, how do you solve this problem? You have to divide first before you talk about multiplying. In BODMAS, you do division before multiplication. And one advantage of that is that division will reduce the number for you, so that it will now become easy for you to multiply. But multiplication will increase the number, whereby dividing might now become a bit difficult for you. So for this question, we have to reduce. We have to do reduction of fraction. This question you're seeing is just like somebody giving you maybe 20 over 2 times 5 over 50. Or 20 over 50 times 5 over 2. So any one of them you want to handle. If you solve this part, whatever you get, use it to multiply anything you get here. Is that okay? So it's a simple thing. Even if you solve multiplication there, don't bother. It's nothing difficult. It's still the same way. Now look at, we have 20 times 5 all over 2 times 50. There is one thing I want to show you quickly. You observe that there is a number in the numerator that ends with the digit 0. You also have a number in the denominator that ends with 0. Under division, basic arithmetics, I taught you the secret, the principle of dividing numbers whose last digit ends with 0. You just have to cancel out the 0. Okay, so in this case, it's serious. The network situation is something else. Something else. Seems like the board is a bit blurred. It's blurred. The network, I won't give up. We must see the end of this topic today. We must see the end of this topic today. Yes. Must see it. Let's see what happens. Still battling with the network. All right, so let's see. Since this 20 ends with 0 and this 50 ends with 0, just cancel the zeros there. So I explained this already under basic arithmetics, division specifically. Okay? Then you observe that you have 2 times 5 in the numerator and you have 2 times 5 in the denominator. What you have in the numerator is exactly what you have in the denominator. And you know whenever you're dividing the same thing, you get 1. So it is simple this way. 2 will divide 2, you get 1. 2 will divide 2 here, you get 1. 5 will divide 5, you get 1. 5 will divide 5, you get 1. See why I told you that this question is an interesting one. So the final result here is going to be 1 times 1 in the numerator. Fact. No time to waste. 1 times 1 will give you 1. Over denominator, you are left with 1 times 1, which will also give you what? 1. So we conclude, therefore, 20 times 5 over 2 times 50 is equal to 1. If you go to multiply this number before you start dividing it, The multiplication process alone is stressful. Yes. You do 20 times 5, although you're going to get 100. All over 2 times 50, you still get 100. If you are fast in multiplication or you're good in multiplication, you'll see that it's 100 over 100. But there are certain types of numbers that might be given to you, and it will become difficult for you to multiply that out. That is why you should have this knowledge of division. If you divide, you get smaller numbers, which will now allow you to multiply. So we are done with this question. Let us look at question number 4. The network is not funny. Let's look at question number 4. Let's look at question number 4. All right, so you can copy what's on the board while I try to work on this. All right, so we're going to look at question number 4. Example 4. Let's see what we have here. So in example number 4, we are asked to simplify, right? Let's see, evaluate. This example what? 3. Seems like I made a mistake in the numbering. It seems like I made a mistake in the numbering. The one we solved before this was example 3. This would be example 4 because we started with number 1 earlier. I don't know. Seems like I've made a mistake. This should be example 4. Number 1 was from our previous class under this reduction of fraction because this is the second class. So this is number 5. Good. And we have this question. Simplify. Simplify 14 times 3 times 3, and then I have times 24 all over 9 times 4 times 28. So we are asked to simplify that, expression on the board. You have to simplify this. Solution. So we have 14 times 3 times 24 over 9 times 4 times 28. All you have to do is simple. Just follow the same procedure here. Look at the numerator, look at the denominator, and ask yourself, which numerator and denominator has a common term that can divide? Now, I can start with this 14. Then compare it with the numbers in the denominator. This is 14, this is over 9. Can 14 and 9, do they have any common term? And in fact, let me tell you, what you have on the board is just like somebody writing 14 over 9. You solve this if it can reduce, times 3 over 4. You solve this if it can reduce, then times 24 over 28. You solve this if you can reduce and then multiply. That is what you have on the board. But if you look at 14 and 9, nothing can reduce them. They don't have common factor. They don't. So you check 14 and another denominator. Okay? All right. 14 and 4, they have a common factor. 2 can reduce them. 2 is the highest common factor of 14 and 4. So you can use 2 to reduce. 2 into 14, you get 7. If 2 divides 4, you get 2. But again, there is something I'm looking at in the denominator, so I don't even want to use 14. I don't want to solve for 14 and 4. I observe that I have 14 in numerator and I have 28 in denominator. 14 and 28. The HCF, highest common factor, is 14. 14 can divide 14 to give you 1. 14 can divide 28 to give you 2. So I want to clear that bigger numbers, right? But it doesn't matter. Even if you want to do 14 and 4, you will still get the same answer if you work it correctly, using 2, like I said. But you know, with good knowledge, with excellent knowledge of multiplication, of course, somebody would have to go with 14. 14 will divide 14, you get 1. 14 will divide 28, you get 2. If you combine your knowledge of multiplication, rules of divisibility, and HCF, this is 1 plus 1. Because I'll get 7 here using 2 to divide, I'll still get 2 here using 2 to divide. I'll now be looking for what else to do. But you see, with this, 14 has cancelled itself. You get 1, divided 28, and gave you 2 directly. So see how I've dealt with this big number. Okay, let us look at, in the numerator, we have 3. In the denominator, do we have any number that would have a common factor with 3? We have 3 in the numerator. In the denominator, is there any of the numbers there that has a common factor with 3? We have 9, 4, and 2. And yes, 9 has a common factor with 3. In 3 times table, you have 9. So 3 can divide 9. I hope you are following, right? 3 can divide 9. Since in 3 times table, you have 9. So I would divide this 3 by 3 to get 1. I'll divide this 9 by 3 to get 3. Good. Next, you have 24. You have 24. And you have 3, 4, and 2 in the denominator. Ask yourself, 24 in the numerator, and then the denominator you have here, 3, 4, and 2. Is there any of them that can divide? And the answer is yes. I really didn't want us to get 1 as our final answer here, but it seems like we are going to get 1. And permit me, I'm going to change this 4, please, since we've not touched it. I'm going to change this 4. I will change this 4. Permit me to change it. I want to change this 4. Let's change this 4 to 3. Let's change this 4 to 3. I'm sorry about that. Should I make it 3? Or let's change it to... Okay, let me change it to 8. Or 6 rather. I'm sorry about that. I don't want us to get 1 as our final answer again. You know, I had to come up with this particular question so that you see that reduction of fraction can take other higher form a little, where they would bring in multiplication there. So please, this is 6, this is 6. Good. All right, at this point we continue. Look at, you have 24 here. You have 3, you have 6, you have 2. You can reduce. 6 can divide 6 to give you 1. 6 can divide 24 to give you 4. To give you 4. 3 can also divide 24. So at this point, the choice is yours of which one to use in reducing. 2 can also divide 24. But like I said, if you have good knowledge, excellent knowledge of HCF, you always go to use HCF so that once you divide, nothing can reduce that part again. I'll use 6. If 6 divides 6, you get 1. If 6 divides 24, you are going to get 4. Are you seeing this right? Now in the numerator, you have 1 times 1 times 4, which will give you 4. In the denominator, you have 3 times 1 times 2, which will give you 6. But hold on. You have 4 in the numerator. You have 3 and 2 in the denominator. Something can still reduce. 4 in the numerator and 2 in the denominator. They have a common factor. 2 can divide 2 to give you 1. 2 can divide 4 to give you 2. I hope you're following what I am doing here, right? By the way, I'm sorry that I changed this number from 3 to 6. Yeah, I didn't want us to get 1 as our final answer again. If I had left it as 3, the final answer will still be 1 as this. I don't want you to start thinking that anytime you see a question like this, the final answer must be 1. Because somebody may start thinking that way. And it's not true. That is why I had to change it. Okay, let us conclude. In the numerator, we have just 2 there. You know, this is 1, 1. 1 times anything is that thing. So you have 2 there. In the denominator, you have 3 times 1 times 1, which is just 3. 2 in the numerator, 3 in the denominator. Nothing can divide them again. So the final thing you have here is 2 over 3. We can then conclude, therefore, 14 times 3 times 24 all over 9 times 6 times 28 is equal to 2 over 3 is equal to 2 over 3. And that is the answer. Let us assume you had something in the numerator that nothing can reduce again. Let's assume you have something in the numerator, another number in the numerator that no denominator can divide. Maybe say 11, for example. And you still have this 2 there. You are going to solve 11 times 2, which will give you 22 over 3. And then you can put in mixed fraction if need be. Can put in mixed fraction if need be in such case. In fact, let me show you something that whenever you do this division, anything that is left, the numerator and denominator, you have to multiply them out. So permit me to write this as 1 times 1 times 2. Please, anytime you do this division, whatever that you have remaining in the numerator, you have to multiply them out. Whatever you have left in the denominator, you have to multiply them out. Let me check the network situation, please. Please, this network, calm down. We are almost done. We are almost done. So the denominator here is 3 times 1 times 1. And 1 times 1 times 1 times 2 will give you 2. 3 times 1 times 1 will give you 3. That's how you got the final answer. Like I said, anything that is left in the numerator, any number left that can no longer divide, that can no longer reduce, you have to multiply all of them in that numerator. Multiply all of them in the denominator. Okay? Because sometimes you can solve a question that can lead you to something like that, where you still have some numbers in the numerator and denominator, not 1. But those numbers, nothing can reduce them again. So you have to multiply them out to get your final answer. Multiply the numerators, get your answer. Multiply the denominator, get your answer. So remember that. All right. I think we are done with this. And although the network tried to terrorize us, but we refused to give up. And that is the spirit of GMAETS41. Your friends, you are GMAETS41 basic class scholars. You want to copy what I do for not giving up. This is how we come to the end of our class today. I'm going to give you your assignment. I'm going to give you your assignment. Solve it, snap, and submit to GMAETS41. How can you submit your assignment? You can submit through the channel community, through the community of this channel. If you come to our homepage, GMAETS41 basic class, the homepage, you will see visit community. Tap it. If you tap it, you can snap and upload your assignment directly to me. Assignment. Reduce the following fractions to their lowest terms. Reduce the following fractions to their lowest term. Reduce the following fractions to their lowest term. So we have 1 30 over 60. 2 45 over 95. 3 54 over 72. 4 18 times 27 all over 45 times 36. So you have to solve these 4 questions and submit to me through our channel community. If you don't know how to do that, you can plead anyone who knows how to submit the assignment like I told you. Click on Visit Community on this channel homepage. And there, you can send a message to me. You can send assignment submitted, and you can send your solved assignment to me. All you have to do, if you solve it in your online school notebook with GMAETS41, your online school with GMAETS41, if you solve it in the notebook, snap it. Okay? Snap it, and then you send it through our community. I will see it, and I will mark it. All right, I'll be seeing you in our next class on Tuesday. All right, so prepare. By Tuesday, I will see you in the evening. Okay, see you in the evening around 7:30, 7:45 to be precise. 7:30 to 7:45, the class will start. Make sure you study what we have treated so far, okay? Make sure you study it. And if you have any question, feel free to send your question to me through the channel community as well, okay? If you have any questions, send it through the channel community, and I will attend to your question. Once again, if you have any question, send it to me through the channel community, and I'll respond to your questions. Always take your studies seriously, okay? Study and study well. As we conclude this class, the network is just messing up a lot. Let me see if I can boost the network a bit. So I'll be seeing you in our next class, okay? Where I will teach you addition and subtraction of fractions. We're teaching you addition and subtraction of fraction, and then fractions with how to order fraction in increasing or decreasing order. Always make use of our channel community to submit any question you might have, all right, or submit your assignment. As a summary to this topic, what have we learned so far? How to reduce fractions. I said that in reducing fractions, there are 3 methods you can use. We have the HCF method, which is the best method. We have the continuous division method, which is still very good method. We have the prime factorization method. It's okay, but I don't usually advise that anyway, okay, for real learning. I don't advise that. So HCF method and continuous division method, wonderful. You can use any one of them. You need the knowledge of multiplication, excellent knowledge of multiplication. Please don't play with that. Memorize a multiplication table very well, from 2 to 9 times table. Secondly, you want to learn the rules of divisibility. You need them. Rules of divisibility very well, from 2 to 9. How would you know that a number can be divided by 2? How would you know that 3 can divide a number 4, 5, 6, 7, 8, 9, 10? How would you know that these numbers can divide a particular number? So those rules of divisibility, you need to learn them very well. On this channel, I have taught that. You have 2 major videos that cover the rules of divisibility. So take them, okay? Make use of this channel very well so that you will be excellent in your school works. Good night. I'll meet you on Tuesday. Bye.